Okay, so let's go through checkpoint 3. So we have these three particles of charge positive q, negative 2q, and positive 3q, right, are fixed along a straight line at a distance r apart. So what is the magnitude of the resultant electric force acting on the positive plus q charge? Okay, so first, if you look at the positive plus q charge, right, you will experience one attractive, one repulsive force. So what is the attractive force? The attractive force is highlighted by the yellow color highlighter. So because apparently you can see, right, the negative 2q will attract the positive q. So this result in the first force. Okay, what about the repulsive force? The repulsive force is actually caused by this positive 3q, because apparently, yeah, this is positive 3q, this is positive q, means that it will actually repel one another. So let's call this force number 2. Okay, let's calculate force number 1 in terms of all the parameters, right? So the force number 1 is q times 2q divided by 4 pi epsilon r square. So you'll get 2q square over 4 pi epsilon r square. Okay, what about force number 2? Okay, force number 2 is q times 3q. And of course, don't forget, divide by 4 pi epsilon, the distance between the positive q and the positive 3q. Meaning it's not r, it's actually 2r, the whole thing bracket square. So of course you can see it's 2r bracket square, 4r square. So 4r square times 4 is 16r square. So the whole thing here, right, force 2 is 3q square over 16 pi epsilon naught r square. Okay, so they want us the resultant electric force. And if you look at this force number 1, apparently you can see that it is much bigger than force number 2. So it means that you can actually do the manipulation, right? So you times 4 throughout. So it's 8q square. This one is 16 pi epsilon naught r square. So you simply just use this minus away this. So 8 over 16 minus 3 over 16, right? The resultant force towards the right hand side should be 5q square over 16 pi epsilon naught r square. So the answer should be C.